How's it going, everybody, and welcome back to our Cisco Enterprise series. In this video, we are going to pick up right where we left off at the end of the last video, and I'm going to help you guys stand up iOS XR for EIGRP v4. So without any further ado, I'm going to go ahead and get into it. So on XR43, this is going to be one of those routing platforms that you're probably not going to see very much of because it is a service provider based platform. So I'm going to log in as Rob and Cisco, and when I do the configuration here, it's going to be a little bit different than what you might have seen. So I'll do a show IP interface brief. I've got it pre-configured already. It's got all the IP addressing done on it. So as you can see, we have our loopback address sits up at the top. We have our management interface if we wanted to plug into our management port, and we have our IP addressing done and all that good stuff. So I'm going to go to global config, and I'm going to type in router, then EIGRP, and then we're going to have to specify our AS number. And then underneath here, we go to our address family first. So we type in address family, and then IPv4, and then unicast. Unicast actually isn't there, so we're going to hit the enter key, and then now that we're underneath the address family, now we need to specify the autonomous system number. So we'll type in autonomous system number is going to be 2, hit the enter key, and if you're never not sure where you're at or what you're doing, you can at any time type in pwd, print the working directory, so you're underneath EIGRP, address family, IPv4. And if you want to see how much you configured, just type in show config. And that'll tell you what you configured so far. Fairly straightforward stuff. So now that we've done that, the next step here is to go do a question mark. And if you notice, there are no network statements, right? You've got nonstop forwarding, you've got the no command, things like that. But what you want to do is you want to specify the interfaces that you want to enable EIGRP on. So in this case, you're going to type in interface, and it's going to be gig 00000. And hit the enter key there, and then I can then go and make whatever other changes I want. If I want to do a neighbor command, I could do that. So what I'm going to do here is I'm going to hit the up arrow, and I'm going to say gig 0/1, and then I'll type in, hit the up arrow, I'm going to type in loopback 0. So I do a show config again. I can see that I've enabled EIGRP on loopback 0, gig 0000, and gig 0001. So now I can go ahead and if I do show IP EIGRP interface, show EIGRP interface, EIGRP not configured. You're like, well, wait, there's config here. Well, the thing with EIGRP, with iOS XR in general, no matter where you're at with it, you have to commit the config. So very much like Juniper. So I'm going to commit the config, and it's going to apply that configuration. Now tell me there is a configuration issue. So what we can do now is we can type in show config failed, and it's going to tell me that EIGRP detected the warning condition. Configuring autonomous system for default VRF when EIGRP is configured using AS number is not allowed. So what I'll basically do is this. I'll do a show config, and I'll just type in, I'll say no autonomous system 2. So now show config. I'll go ahead and I'll hit commit again. And there it goes. I went ahead and it accepted my configuration. Now if I type in do show run EIGRP, or the section EIGRP, I'm still very do show run begin EIGRP. So there's the configuration that I need to apply. So now that I'm there, I'm in good shape. So now XR has been configured. Now what I get to go do is I need to go to the other routers, and I'm going to type in debug EIGRP. We'll say IPv4 or packets, and which interfaces we want to do. I'm just going to hit the we have to pick which specific update. I'll say update. Update, and then I'm also going to say packets. Do I have any other options besides that? No, I don't. Act hello, query, request. No, that'll be fine. So I'll do that, and if I do a show logging, it'll tell me that my logging for console is debugging. So perfect. So now what I'm going to go do is I'm going to go to 28. I'll work my way around all the routers. I'll type in router EIGRP2, network of 2.28.43.0, 0.0.0.255, and we should form an adjacency with on gig 0/1 XR43, and I should be able to do a network statement for 2.0.0.28, 0.0.0.0. Then I'll do the exact same thing on 29. Router EIGRP2, network statement of, in this case here, since I've got 229 for both interfaces, I'm going to type in 2.29.0.0, 0.0.255.255. So any interface starting with 2.29 is going to automatically get enabled for EIGRP. And then we formed an adjacency with 43. I'll type in network of 2.0.0.29 and then 0.0.0.0, just like that. And last but certainly not least, on 61, we're going to go to network of 2.29.61.0, 0.0.0.255. And so we should form an adjacency with 29. Okay, perfect. So on 61, if I do a show IP EIGRP interfaces, I have gig 1 and gig 2 enabled for EIGRP. I have one peer on each interface. If I do a show IP EIGRP neighbors, I am peered with both. Things are looking pretty good. Eventually this round trip timeout will come down from 5,000 down to 100 once the network stabilizes. Okay, so we've looked at the interfaces. So who are we directly connected to? Which interfaces do we have EIGRP enabled on? Then who have we formed EIGRP adjacencies with? That's the neighbors. And then the next one is going to be what routes have we learned from our EIGRP peers? And that's going to be the topology table. So we're working our way from what interfaces are enabled for EIGRP, what neighbors have we formed with EIGRP, adjacency wise, and then topology is what routes have we learned via EIGRP. And then we have a few. So that's looking pretty good. So notice how everything in this column right here is a capital P for passive, which means EIGRP is stable. Nothing's going on, everybody's happy. So what we'll do instead is, for the next step, and we can see based off the output, we can see that we have you'll notice that we have the successor, right? And just remember we talked about, we have this is the reported distance, this is the local distance. So I'm directly attached to this. So 2816 is my reported is my local distance to that neighbor, and then in this particular case here, I would get 3072 is going to be my computed, or my, sorry, the difference between those two. I apologize. So the difference between these two, if you take 3072 and 2816, that is going to be your local distance to it. So whatever that difference is, I'm like 120, 100 and something maybe. So we have that. So the next thing what we would do is we would do see what routes get moved from the topology table into the routing table. We do a show IP route. And we're going to see some EIGRP routes in here. So we're going to see 28 for R28, we're going to see 29. For R29, we're going to see 43. For our XR43, we don't see one for our local. If you notice that, we don't see one for our local. And we see a bunch of EIGRP routes that are /24s. Notice that over here we have our 90 and which is our administrative distance, and we have our metric. This is the composite metric that EIGRP calculated. Everything's looking pretty good there. We have our next hop be a 28. So I'm on 61. In order to get to router 28's loopback, I would go via 228.61.28, and it's been up for 3 minutes and 43 seconds via gig 1. And that's really all the routing table is. It's just a GPS for you to figure out where you've got to go on the network. So that is pretty much how that works. Like I said, nothing terribly difficult to understand in terms of that. So now that I've covered those details, we are at the end of this video. So if we were to go back over to our CCA blueprint, we've taken a look at just general operations. We've taken a look at the topology table, right? That's all looking pretty good. We haven't really gone into reported distance and how that's calculated or how you would discern that. We'll take a look at that in an upcoming video. We haven't looked at the packet types either, but we sort of have. We've looked at acknowledgement, we've looked at updates, things like that. So we've kind of understand that. We're not really going to be able to demonstrate a stuck and active. There's technically a way to do it, but it's complicated. So I'll see if I can't get that to work. But we're going to be definitely taking a look at the metrics more in detail. So we've taken a look at the topology table. We've loosely looked at the packet types, but I'll dive into that more in detail in an upcoming video. So for right now, we've covered a fair amount of the information that we need to know about in order for this to all work. So with that being said, I'm not going to go any further than we already have. You and I will go through this in more detail in an upcoming video so we can get down to reported distance, local distance, feasible distance, all that type of stuff. Get down to the weeds of how it actually works so that it's easier for you guys to see. But just to recap, configuration-wise, all we've done, we do a show run section EIGRP. We've enabled EIGRP by turning the routing process on with autonomous system number 2. And we've gone through and we've used network statements to dictate which interfaces we're going to allow EIGRP to run on. Now, I will mention that down the road, when we start getting into, once we've covered EIGRP at a little bit of a deeper level and stuff like that, we will be doing things like BGP peerings here. So I will be talking about, well, what if you accidentally enable EIGRP on this interface? Well, how could you prevent that from happening? So we'll talk about that more in detail and why you wouldn't want to, on like LAN segments over here, when we get down to here, why you wouldn't want to enable EIGRP to form or OSPF to form adjacencies over the LAN-facing interfaces of our distribution block. Why wouldn't you want to do that? So I'll talk more about that. That's in more of a higher, resiliency and redundancy and how to be careful where you're doing that. We'll talk about how passive interfaces can help with that, how EIGRP stub routing can help with things like that. So with that being said, I've covered everything that I need to in this video, and until next time, guys, if you haven't already done so, please leave a comment in the comment section below if you have a question, comment, concern, or some feedback. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.